Welcome to Equations and Inequalities and All Things Algebra review. Because it's a lot of information, you'll see, write a lot of the notes in, but there are a few things that we're going to add and then things I just want to draw your attention to. So section by section, how do we solve equations? And when you solve equations, you're trying to find an answer. You've got an equal sign, that's why it's called an equation, and you're trying to find an answer to something. So you do that by using the inverse operations to undo the equation. So if you had something like x plus 5 equals 8, x is being bothered by plus 5, so you're going to subtract 5 from both sides. Because subtraction is the inverse operation, it's the opposite of plus 5 is subtract 5. So addition and subtraction undo each other. Multiplication and division undo each other. If you had this equation, 6x equals 36, that's 6 times x. And to undo multiplication, you do division. So we would divide both sides of the equation, both sides of the equal sign, by 6. 6 divided by 6 is 1. Bring x straight down. Bring your equal sign straight down. 36 divided by 6 is 6. Then you should always go back and check to see if you were right. So where x was up here, you put in 6. 6 times 6 is 36. And if you checked it, you put a little check there. And that's what we mean by checking your work. Okay, so inequalities, that means when things aren't equal, right? Greater than, less than, greater than or equal to, that sort of thing. To check your work, so you do the same steps. So you do the same steps as here. But then to check your work, choose a value that's within the constraints of the inequality and plug in the number. That's quite wordy. We'll talk about what that means. If it's incorrect, then you should get a true statement. If it is correct, you should get a true statement. If it's incorrect, you need to go back to the drawing board. So here's an example of what they're talking about. When we go to solve this, 2x is greater than 20. That's 2 times x. The inverse operation of times is divide. Divide both sides by 2. X is greater than 10. So now this is where that statement about find something within the constraints of the inequality. So x is greater than 10. If we want to make sure that we did that correctly, let's try x equals 11, because 11 is greater than 10, and we'll put it in and see if it works. So 2x is greater than 20. 2 times 11 is greater than 20. 22 is greater than 20. So that checks. So we're correct here that x is greater than 10. Okay. Graphing inequalities. And graphing would be, graphing on a number line. Graph the inequality statement on a number line to represent the possible solutions. And remember, you fill something as a solid dot, it means that value is included, and an open circle if that value is not included. So this would be something like, this is a very short number line, but if this is 3, the world's shortest number line here, if that's 3, and I have this going this way, that means numbers that are greater than or equal to 3, because I put a big circle there. Okay, inequality vocabulary. These are worth memorizing. This means less than, or fewer than, or smaller than, or below. Less than or equal to means less than or equal to. Maximum, at most, so 5 is less than or equal to x. Not more than, not greater than. This is greater than or equal to, at least, minimum, not less than. And this is greater than, more than, above. And that's our friendly equal sign. Okay, finally, writing equations and inequalities. If we were creating them, determine what's being solved for. Choose a variable, that's a letter, number of rides, number of feet, etc. Determine the result of the situation. So is it total cost or total height or the difference in weight? So I just came up with some scenarios here. your situation could be there's cost $3 a person to get into somewhere. So what's the total cost going to be? Well, it's going to be $3 times X would be the number of people going equals total cost. So if we said 3X equals 30, you could figure out, oh, okay, 10 people are going. In this situation, 15 miles plus mystery number of miles is total distance. 15 plus X is 24. Moving along. Next page is about the coordinate plane. It's a really fast review of the coordinate plane. This is the origin. You always start at the origin. That's 0, 0. The quadrants are numbered. And this one is the one that you started learning about where everything's positive. This is quadrant number 1. And for some reason they go counterclockwise. This is number 2, Roman numeral 2. This is number 3, Roman numeral 3. This is number 4, again, if we were going counterclockwise. So everything over here, and this is where you started learning about the coordinate plane. Everything over here is positive, positive. And this is X, Y, right? Ordered pairs. Always go X. The order is X first, then Y. When you get over here, X is negative, but Y is positive. X is negative, Y is positive. When you get over here, X is negative and Y is negative. So this is negative, negative, quadrant 3. And this one, quadrant 4, X is positive, but Y is negative. X is positive, and Y is negative. Okay. We're not going to do reflections, but let's talk about what these numbers are here. Let's zoom in a little bit on this. Okay. Point A, to get the coordinates for it, we always start here. It's negative 3. You might as well write that down before I forget. Negative 3, and then up 2. So it's negative 3, positive 2. Let's just do D since we're up here. It's 1, 2. So positive 1, positive 2. So D is 1 and 2. B is negative 3. We always start with the X. X is negative 3. And then we come down to negative 3. So it's negative 3 and Y is negative 3. So B is negative 3, negative 3. And then C, it's positive 1, but then negative 3. It's 1, negative 3. Okay, moving along. Algebraic representations. So this is, what is algebra used for? And how do you show it, in a chart or on a graph? Let's see. Let's do this. Let's say we had this information in a chart. And remember, you always want to use your chart or table first before the equation. Even if they present it like this with the equation first and the chart over here, always start with your chart and use your chart to let you create your equation. So let's say we had this data. 0, 1, 2, 3, 4. Over here, X is 0, 1, 2, 3, 4. And our values for Y are 0, 50, 100, 150, 200. And when we're writing our equations, the format we use is Y. Y is always going to be over on this side of the equal sign. So let's look at what we have to do to get from X to Y. 0 to 0, that's not helpful. But from 1 to 50, it looks like we multiply by 50. 2 times 50 is 100. 3 times 50 is 150. So to get from X to Y, let's put a dot instead of an X because that will just get confusing. It's times 50. So X times 50 is Y. X times 50 is Y. So Y is 50X because we have to write it in that Y is first format. Y is 50X. And if you are unsure about that, pick one of these values and stick it in. This is X, so let's look at Y. Y of 200 equals 50 times 4. Yes, that works. So this is our equation. This is our chart of values. We use that to generate our equation. Y is 50X. And if we look at this situation over here, guess this is something about earning money. Weeks, time goes by, money's getting saved. So it looks like someone's saving $50 a week. Remember that the bottom of a graph, this is always the independent variable. We'll talk more about that down here. This is independent variable, and this is dependent. So in this situation, the amount of money that this person is saving depends on how many weeks go by. The more weeks go by, the more money is saved. Okay, so 0 weeks, the very first week, there's no money. No time has gone by and no money saved. But week 1 is $50. Week 2, $100. Week 3, $150. Week 4, $200. So, not sure if we could extend this as a line or not. Remember, a line is when something's happening continuously. You know, I'm not sure if someone's paying this person, $50. If they worked a half a week or a half a week went by, would they get 25? Who knows? So we don't really have enough information to decide if we're going to connect those dots. But you can see that it's a linear. It does make a line, which multiplicative relationships do. They make a line. Okay, moving down here, independent quantities. Independent is always x. And this is x, right? This is x and this is y. Dependent, that's always going to be on the y-axis. This is the x-axis, that's the y-axis. Dependent is on the y. So we're going to fill in this table about the situation, create our equation, and then make a graph. So let's come up with a situation here. The cost of a snow cone is $1.50. What is the total cost, and they're using C for that, of S, which is the number of snow cones. So I hope you agree that the total cost is going to depend on how many snow cones you buy. Let's get our equation going. If you buy 0 snow cones, it costs you $0. 1 snow cone is $1.50. 2 snow cones, here, let's get our dollar signs out of the way. 2 snow cones is $3. 3 snow cones is $4.50. 4 snow cones is $6. So to get from S, the number of snow cones, which is the independent variable, and I said always X, that means it's going to be graphed on the X-axis, the independent. The dependent variable is the cost. The cost depends on how many snowflakes. So to get from S to C, you're multiplying by $1.50. So the number of snow cones times $1.50 is going to be your total cost. So the cost is going to be snowflakes, snow cones times $1.50. So the cost is going to be $1.50 times, and let's make that S really curvy so it doesn't look like a 5. So our equation is the total cost is going to be $1.50 times however many snow cones you get. So time to graph. 0 snow cones, $0. 1 is $1.50, 2 is 3, 3 is $4.50, 4 is $6. Now this is a situation where it's really clear, even though this makes a line and it's so tempting to connect those dots, it's linear even if you don't connect it. It makes a line, it lines up. You don't connect them though. You don't say, oh, I want 1.5 snow cones, or I want 1.7 of a snow cone. You either get 0 snow cones, or 1, or 2, or 3. You don't. This isn't a situation where you're going to connect. So I'm going to go in and do just a couple little problems from inside here. So turn to 327. Let's see, where are we? Okay. It says at the top, ready to go on 11.1, 11.2, 11.3. Let's solve an equation or two. Let's zoom in on this one. Q minus 7 equals 18. Q is being bothered by minus 17. So let's add 17 to both sides of the equal sign, both sides of the equation. Draw a line straight under, bring down everything that's not eliminated. Q minus 17 plus 17 goes away. Bring down your equal sign. 18 plus 17 is 35. Now go back and check. 35 minus 17, I know that's 18. 18 equals 18. So we did a check. Here, let's do this one. 3a is 57. A is being bothered by times 3. So let's divide both sides by 3. 3 divided by 3 is 1. A equals 57 divided by 3 is 19. Let's go back and check. 3 times 19 is 57. 57 equals 57. That is a check. Let's do an inequality. Let's graph an inequality here. There are fewer than 8 gallons of gas in the tank. Let's start with 8. I mean, we can always circle it and then decide whether we're going to fill it in or not. There are fewer than 8 gallons of gas in the tank. Are there 8 gallons of gas in the tank? No. There's not 8 gallons. If there's fewer than 8 gallons, so that has to stay open. I'm going to go that direction. Let's look at this next one. There are at least 3 slices of bread left in the bag. Let's circle 3, and then we'll think about whether we're going to fill it in or not. There are at least 3 slices of bread left in the bag. Could there be 3 slices? Yeah, there's at least 3. There's at least 3, so 3 is one of the possibilities. There's at least 3. There might be more. There's at least 3. That means 3 or more. So our arrow is going to go this way. Let's see. Couple more we should do in here. Let's switch to, let's see, page 359. Wherever that went to. Where's 359? Okay, I can't find 359, so I will just show you here. 359, it's ready to go on. It has 12 at the top, 12. John buys packages of pens for $5 each. Identify the independent and dependent variables. Well, I hope you'll agree that the total cost depends on how many pens he buys. Here, let's zoom out a little. The total cost depends on how many pens he buys. So it's always easier to do the dependent one first. The total cost depends, that means the cost is dependent on how many pens he buys, and that's independent. If we come down here and we have to write an equation from a table, this is super important to know how to do. You look at x and y. How do we get from x to y? Well, here it's times 7, because 3 times 7 is 21, 5 times 7 is 35. So y is 7x. And if you're not sure that's true, let's look at something. Y is 70, x is 10. Is 70 7 times 10? Yep, so that one's right. This one, how do we get from x? This is x and this is y. How do we get from x to y? It's plus 12. So y equals x plus 12. When you have something like this, graphing it, don't go straight to the graph. Make a table and fill it in. So x and y, if x is 0, y equals x plus 3. If x is 0, that means y is 3. If x is 1, 1 plus 3 is 4. If x is 2, then y is going to be 5. So over 0 up 3, over 1 up 4, over 2 up 5. Let's come over to this one. Same thing. Make a table before you start graphing something. 0 is always a safe place to start. Y equals 5x. So y equals 5 times 0. Those are both 0 then. If x is 1, y equals 5 times 1, so it's 5. If x is 2, 5 times 2 is 10. So let's graph that. 0, 0. Over 1 up 5. Over 2 up 10. Boy, that's tiny. Let's see if there's anything else I wanted to go over. I think that might be it.